We're going to be talking about lesson 4, conservation of energy. There's two kinds of energy that we have talked about. We have talked about gravitational potential energy and we have talked about kinetic energy. And in this case, they're saying that the energies are going to be converted from one form to another, but within a closed system, the total energy doesn't change. So say for example, if I have a roller coaster ride, and I'm telling you that right at the top here, the train wasn't moving. So do you see how gravitational potential energy is really high, but at the same time, kinetic energy is equals to 0. As the object comes down, it's going to start gaining speed, but because it's dropping in height, I'm losing potential energy. Right at the bottom here, I'm going to have it all be kinetic because now it's going the fastest at the bottom. But then at the same time, because I am going right at the bottom of the hill, my potential energy is 0. But what this law of conservation of energy is, if I add up all the energy in here, and if I add up all the energy in here, they should be the same. Okay, so and that's what this is. And as in any other point, say this point, I have a bit of kinetic and I have a bit of potential. But if I add them all up in here, it should also be the same at any other point. Any other point. The total energy stays the same. And that's a law of conservation of energy. Okay, so you will need to know how to write this out. The law of conservation of energy states that energy cannot be gained or lost. It can only be transformed from one type to another. And they said that the total amount of energy, key thing is in the closed system, meaning nobody's adding any extra energy into it, must remain constant. Okay, so consider the situation. If you throw the ball into the air, you would first of all do work and launch it into the air. But once it leaves the hand, so if this is your hand, okay, you toss the ball and it's going really fast when it leaves your hand, right? You're doing work, giving it the energy is going up. So at this point, I have it going really fast. So kinetic energy is really big. So that's what this point is. Okay, so I'm going to color code this. So this is yellow and that goes to this point. I have really high, but okay, and then what happened is as the ball rises, okay, as it's rising, what happened is the speed will be reduced. Okay, and that means it's losing kinetic energy as it is going. All right, so this is talking about right here while it's going up. What happened is your EK will be decreasing, but at the same time your EG is increasing. Okay, and that also goes to here as the kinetic energy transform into gravitational potential energy. So that's what this is. And so at the highest point, you take that out, at the highest point the speed have to be 0. I don't know if you remember when we did the acceleration due to gravity question and we say at maximum height it will stop. Gravity will slow it down as it goes up, eventually get to the point that it's going to stop and it's going to start heading down. So speed is 0 at the top, meaning right at the very, very top, my kinetic energy is equals to 0, but now they're all going to be potential. And then the process now go opposite. Then the process repeat, right? So the object is now going to start to fall. And as the object is falling, we now have the opposite process, right? On your way down, the process reverse. So the ball will lose gravitational potential energy and gain the kinetic energy. So around here, what's going to happen is I'm dropping height, so I'm losing gravitational potential energy, but I'm picking up speed again, so I'm increasing until they get to the point, if it's the same level here, what happened is they're going to be all EK and no gravitational potential energy. I'm going to add the no gravitational potential energy. Big hint for you, I would totally draw this picture in my study notes. Hint, I didn't hint you, did I hint? Make sure you have this picture down, okay? All right. So let's work out what is the total energy. We sometimes just call it total energy, ET. And basically to find ET is at a certain point, okay? EK equals to EG. I'm going to ask you to add it to here, okay? Add at any point. Okay, you're gonna pick that point. You find this EG, you find the EK, and you add them together. That's the total energy at that point. So that's why they put together the equation, because they know EK is half mv squared. We learned that in the last lesson. And then EG is mgh, so we would add them all up. All right, so overall, this is the law of conservation of energy again. Okay, the total energy at one point equal to the total energy at the other point. Total energy at one point must equals to the total energy at the other point. So we usually use A and B to represent the problem. I would even replace it by just saying EA, meaning E total at A. Okay, so I replace it like this when I do my problem. So I start off with this and I would write this out. All right. Okay. But in reality, law of conservation of energy, it still stick, but they are not all staying at mechanical energy. Just like when we did the mechanical advantages, I don't know if you remember from Unit 2, in reality, frictions are always there. Okay? It would have removed some of the thing. And when you go to Wonderland, I don't know if you ever hear the sound as the object is moving up, and then when it's going down, you would hear the like all the sound. These are energy, sound energy, heat energy as friction. These are often called the wasted energy, right? So that's why if you actually look in real life, if there is friction, the roller coaster will go lower and lower unless they have like a belt to bring it back up. Like there is probably some sort of motor to help it happen. If not, the hills will decrease in height because it just won't make it there because energy is being lost along the process. But in the imperfect world of physics, we assume no friction when we do these questions. Okay, so in physics class, when we do the conservation of energy question, we assume no friction. So we assume all the energy just all turn into either kinetic or potential. That's our assumption. Okay, with questions like these, it's always good to draw a picture. And on the picture, you would label 2 points, point A and point B. And at each of the points, I want you to note the speed and the height of each of them. If there's 0, you write down 0. If it's a question mark, you write down a question mark. And this is the rule this is the rule that I want you to start to get used to. Okay? All right, so let's read the question. A 0.25 kilogram ball is thrown straight up with an initial speed of 18 meters per second. How much kinetic energy does the ball have at the start? Okay, that is the old question, so I don't even need a picture for 1A. So let's just draw 1A. It's asking you what is the kinetic energy, and they tell you the speed is 18. So speed is 18, and the mass is 0.25. And the equation for EK is 1/2 mv squared, 1/2 mv square. Plug everything in, punch it in your calculator. So 0.5 times 0.25 times 18 square equals to 40.5 joules. Okay, part B is asking you how high. This is the part that now you need to use the conservation of energy. So I'm going to draw a picture. I'm going to follow this rule, okay? I'm going to draw a picture. At the bottom, I'm going to call this point A. And at every point, I'm going to write the H and the V. Okay? From the question, it tells me at the bottom, point A that I called it, has an initial speed of 18, and it has a height of 0 because that's the lowest point that you have. Okay? The ball gets tossed upward, and I'm going to call this point B. They're asking you how high would it go. So you don't know what this is. Okay? There is a hidden message here. They're basically asking you what is the maximum height. Because when you know it's the maximum height, this is something hidden. You need to know that the speed have to be 0 when it hits the maximum height, because it's going to start coming down. Okay? Unfortunately, this is something that you will need to know. It's like, this is tricky. This is the part that people often missed. Okay? All right, so let's keep going. I'm going to go back to the format. I need you to make sure you do these two lines first. Okay? Just copy it out. So on your study note, if you have this written out, just rewrite it out. It's not a hard question, but it's a messy question. I know EA equals to EB, so it's going to be, go back, like honestly, go back to this and copy it. Okay? So I have 1/2 MVA square plus MGHA. Do you see how this part, I'm going to make it smaller, this part represent these guys, right? These are the value that I would use in there. Okay? Equals to 1/2 MVB square plus MGHB. So copy this out. This is very important. Okay, and then I'm going to color code this. This refers to this. All right, so now I start plugging things that I know. I have everything that I need. So point A, I'm going to look at the green part and I'm going to start subbing things in. So half MV square, notice I'm just looking at what's in the green, plus mass times 9.8 times 0 equal half MV is 0 square, adding MG, and then H is my unknown. Sorry, I'm running out of room. Okay, the next thing I'm going to do is anything in the 0. If you actually look ahead of the game and you'll be like, well, at A, if height is 0, I'm totally okay if you just cancel it here. When something is 0, that whole term is gone. Okay, and then if you realize at the top at point B, V is 0, if you want to cross that out right away and not write the rest of it down, I'm totally okay with that. Okay, but the other thing is if you know that this is 0, so this term is gone and this term is gone. Okay, then I'm going to keep going. I'm going to figure out what this side is. Okay, if you look at part A, you already did it. So if you want to just write down 40.5, that's good. Okay, the other thing that I'm going to do now is I'm going to be working out the total here times the H. Okay, so 0.25 times 9.8 is 2.45 H. Okay, the next step of math that you would need to know is I'm going to divide both sides by 2.45. Are you okay with that math? Okay, so I'm going to divide both sides because I want H on its own, right? So I'm going to divide both sides by 2.45. So 40.5 divided by 2.45. I have worked out that H is, because these two are now gone, is equals to 16.5 meters. Alright, so that's part B. Question is not hard, just long and has math. Okay, so I'm going to repeat the question for part C. Part C is asking how high would the ball be when the speed is 10? I'm no longer up here. Okay, I'm somewhere in the middle. They're telling you somewhere in the middle. I'm going to call this, like I'm going to redraw the picture. Okay, so I'm going to redraw it on the next page. I would still use A, the point A that I have, because that's what's given to me. You can use point B too. But I'm going to pick EA equals to EC if I call this C. Okay, so I'm just going to add a new page. So I'm going to repeat the question. I know the mass is 0.25 kilograms. That was given in the question. And I know that I was given in the question point A has a height of 0 and have a speed of 18. I'm just copying it out because I don't have enough room on the other page. And now I'm dealing with another point. You can still call it B if you want. I'm just going to call it C just so you know it's not the same point that we did. They're asking you what is the height. So height is question mark if the speed is 10. Okay, so I'm going to redo what I did just now. Okay, I know that because of conservation of energy, EC is equals to EA. And then we also talked about, we're just going to copy this out. So 1/2 MVC square, be careful now, right? Plus 1/2 I don't know why I flip it. You know what? It doesn't matter that I flip it, but I'm just going to not flip it. I'm just going to start EA equals EC, just so you're used to the A on the left-hand side. Okay, I'm going to repeat this question, but instead of B, I'm going to use C into the equation. Okay, because I changed this to a C. So 1/2 mVA squared kinetic mgHA is equals to 1/2 mvc kinetic, that is at C, times mghc. If in doubt, just copy the equation out, right? Have your study notes in front of you. You don't have to memorize it. If you understand the concept and be able to write it out, that's great. At this point, just follow the steps. Okay, next thing I look for, I cancel the 0. I see that H is equal to 0 at point A, so I can actually cross this out. There's no more zeros in it. I cannot cancel anymore. Now I'm going to sub things in. So remember how we color coded it, right? We are going to be careful. Okay, point A. Oops, super big. I'm just going to make it smaller. Point A, I use these information. Okay, point C, I use these information. See how nice and clear that I'm following the format so I don't get confused which A, which C, and all those stuff. Alright, so let's start writing the math. So I have now 1/2 mass is 0.25, VA is 18 square, equals to 1/2 M, VC is 10, adding M, G, H. Work out what each of them are. So I'm going to work this out. We already did that from part A, right? That is 40.5. Okay, so this is 40.5 equals, now I'm going to work out the second term first. You're going to do your math properly, okay? So I'm going to punch this in the calculator and figure out what that whole term is. So 0.5 times 0.25 times 10 squared equal. So 12.5. And then I'm going to also clean up the second group. So I'm going to go add. I'm going to work out what this guy is. So 0.25 times 9.8 is 2.45 HC. The height at C. Alright. Now it's math. What do I do? What do I do next? Okay. Hopefully you're okay that I have to deal with this first. Okay. So I'm going to have to bring this over. This was adding, so when I bring it over, it's subtracting. So 40.5 minus 12.5 is equal to 2.45 HC. So let's clean up the 40.5 minus 12.5. That gives me 28 equals to 2.45 HC. Divide both sides by 2.45. So I'm going to write this out. You don't have to if you understand the math rearranging. I just want to make sure you guys are doing it good, right? So HC would work out to be 11.4 meters. 4-mark question is really big, okay? So make sure you follow the format. Okay, question 2. A 56 kilogram dives from the edge of a cliff to the water that is 4 meters below. If she runs at 8 meters at the instant she leaves the cliff, the time she's leaving the cliff, determine the following. A. Okay, let's just draw the picture first. Okay, so she's at the cliff. So this is the point that she's starting at. So I'm going to call this point A. We have the mass equals to 56. And at point A, it's 4 meters above the water. So this is water. Okay, this is point B. The height at the top is 4. The height at the bottom is 0. And then it tells you if she's running at 8 at the instant she leaves the cliff. So when she's still at point A, she has 8 meters per second. Determine the following. Part A, I want you to find EG. sorry, let's read the question. Her gravitational potential energy relative to the water when she leaves the cliff. So they want you to find what is the EG at point A. Okay, EG, the equation from yesterday, is mgh, and I'm using the height of A. mgh. So 56 times 9.8 times 4, 2195.2. Unit is joules. Okay, part B. Kinetic energy when she leaves the cliff, meaning point A again. Okay, so part B would like you to find EK at A. EK is 1/2 mv squared, and the speed at A is 8. So 1/2 mass times 8 squared, v squared, 0.5 times 56 times 8 squared is 1,792 joules. Okay, part C. So this is leading you step by step. Okay, part C, total mechanical energy when she leaves the cliff. So part C is asking, what is the total energy at point A? To find that, if you go back to what is total energy is when it's kinetic adding potential, right? And I already found them all. So at point A, it's going to be gravitational potential energy at point A, adding kinetic energy at point A. So 2195.2 adding 1792. I'm going to add them together, and I got 3987.2 joules. All right, part D, it's like, do you understand the physics? They're asking you, what is the total mechanical energy when she reaches the water? Meaning they would like you to find the total energy at point B. Ooh, I don't know what I'm doing. At point B. So EB. Okay, part D, if you understand conservation of energy, EA equals to EB. Whatever the total energy at A would equals to any other points in the system. So that means there's no math involved. You just need to, I understand the physics concept. The total energy has to be the same. Therefore, it's that. Okay, finally, last question. Find the speed when she enters the water. So they wanted to find that. Okay, so let's keep going. So part D, they're asking you, what is EB? So you can totally use this equation and plug everything in and redo everything, but we already have the EB. You can actually just use this, right? I already have at point B what the total energy is. We found it to be whatever that total number is. So I'm actually going to use EB is equals to EK at B, adding EG at B. Okay, I already have EB, which we found, right? So 3987.2 equals to, the height is 0 at the bottom. That means this term is gone, right? The height relates to the gravitational potential energy. So I only now have what is the kinetic energy at B, which is 1/2 mv squared. Okay, plug in my value, 3987.2 equals to 1/2 mass v squared. This is the part we might struggle a little bit with the math. Just go step by step. Work out 0.5 times 56 first. This is 28 v squared. Okay, just follow your step for math. Divide both sides by 28 so that I can now get rid of this number, right? So 3987.2 divided by 28, 142.4 equal v squared. So how do I get v on its own? Hopefully you're good. We have to take the square root. You do need practices with these, right? They're math, and sometimes you need more practice. So v, took the root of it, it equals to 11.9 meters per second. Ooh, super long question. Okay, finally the last one. The roller coaster is shown in the picture. The total mass of the people and the car is 225 kilogram. Assume the car is moving at 3 in point A. What is the total mechanical energy at point A? Okay, point A is up here, and just they already drew the picture for you, so I'm just gonna finish it off. At each point, we write the H and the V. They tell you that at point A is going at 3, so I'm gonna write at point A, the V is 3. From the picture, we're gonna put the height is 20, okay? And so for part A, they're asking for total mechanical energy at point A, which I know that is EKA adding EGA. So I'm just gonna plug them all in, and or you can use the other equation, right? 1/2 mva squared adding mgha. Throw in the information. I know the mass is at 225 kilogram. So 1/2 times mass times VA, they gave me that is 3 to the square. That's a common mistake, right? People don't remember to square it, so make sure you punch it in the calculator properly. M is 225, G is 9.8, and the H is 20. Okay, you can punch it one shot in the calculator. So I have 0.5 times 225 times 3 squared, adding 225 times 9.8 times 20. There's no rearranging needed. So the answer I got is this. When number gets this big, I often like to re-punch in the calculator to make sure that I'm getting the right things. There are careless mistakes happen on the test. Okay, B. Calculate the speed of the car at point B. So they want you to know at point B. So I'm just going to change the color. I'm going to do the same thing. I'm going to write the H and the V for each point, which is point B is what I want. The height is 0. The speed is what I'm looking for. Alright, so for part B, I'm going to use the conservation of energy. I'm going to use point A, and I'm going to help me find out at point B. Okay, I already worked out what EA is, so I'm not going to write everything out. I'm going to write my answer down from part A, but I do need to expand this out. Okay, I do need to break it into the kinetic and the potential at each of the point. Okay, and then look at the number. Number is 0 for the height, so I can now cancel it and check this. Okay, I'm left with 1/2 mv squared. So 45112.5 is equals to 1/2 mv squared. 45112.5 is equals to 1/2 mv squared. Okay, expand out the 0.5. It's 112.5. So I just multiply these guys out first. Divide both sides by 112.5. So I'm going to take the 45,112 and I'm going to divide it by the 112. 45112.5 divided by 112.5. So V squared right now equals to 401. Okay, so I got this equals to 401, and then now I take the root to find the V, so I get 20 meters per second. Last part, calculate the height at the track at point C. So now I'm going to deal with point C. Point C is right here. And they tell me that the speed is moving at 7 at point C. So just like always, write the H, write the V. Okay, the height is what I'm looking for. The V is 7.0. Okay, part C, using conservation of energy. If you would like to, you're totally welcome to use point B as well. But because I already found EA, it's just easy to do EA equals EC. If you understand the physics, any points, if I ask you on a tricky question, if I say, how many points on this roller coaster have the same total energy? Some of you are going to say 4 because there's A, B, C, D label there. But what really is the answer is there's infinite number. Any point on this roller coaster, they have the same energy. Okay, so I'm going to stick with the A just because I already found it in part A. And I'm going to equal it to EC. Okay, so EA I already found. So I'm going to write out what EA is. And EC is the kinetic at C, adding potential at C. We've been doing it repetitively for a while now. Hopefully you're starting to get used to it. It seems really long, but it's so repetitive. It's the same thing over and over again. Okay, so I'm going to expand things out. I don't have anything that says 0 in here, so I cannot cross out any term. So I'm going to have to write out both equation, both kinetic and potential. So 1/2 mvc squared, adding mghc. Plug things in. 1/2 m v at c is 7, adding m g h. Work out the middle term first. So 0.5 times 225 times 7 squared is 512.5. Adding, expand this guys out, 225 times 9.8 is 2205 times HC. Move this over by subtracting. So 45,112.5 minus 55,112.5, it equals to 2205 HC. Work out the left side. And then divide both sides by the 225, 2205 HC. So the height work out to be 18